Hi class, in 13.4, the learning targets, we will be calculating the area of trapezoids and we will be writing a formula for the area of a trapezoid. Remember, you can add this to your semantic word map where we are housing all of the formulas in order to make sure we understand them for our celebration. If you take a look on page 863, we're actually going to look at the lesson introduction to get an understanding of how we are going to start today. It says, in most classrooms, a projection screen is hung above the blackboard. Generally, the screen is located higher than where the projector sits. To view images on the screen, the projector must be tilted upward. This tilting can cause keystoning, which is a distortion of the image. A normal image and possible distorted image are shown. So you can see those two examples down at the bottom of the page. We're going to use those heading into 13.4 today and looking at the keystone effect. If you turn to page 864, problem number 1 asks us how distorted. So you're going to refer back to the two pictures on the previous page in the lesson introduction. What I want you to do to get started is answer questions 1 through 3. I'm going to go back to the images on the previous page so it's easy to understand the answers that you should have come up with. For number 1, describe how the normal image from the lesson opener has been distorted. You can see that it is stretched at the top and narrowed at the bottom. For question number 2, describe the shapes formed. Both images you can see have 4 sides. The normal image is a rectangle and the distorted image is a trapezoid. For question number 3, if you're looking at which image do you think has a larger area, the normal image appears to have a larger area because both look to have the same height and the same width at the top, but you can see that there are different widths at the bottom and the distorted image is a little narrower, so maybe the normal image does have the larger area. After we work through everything in 13.4 for problem number 1, we'll be able to answer that question. Let's take a look now at the bottom of page 864. Number 4, it says the normal image and the distorted image are shown on the grid. Each square on the grid represents a square that is 4 inches long and 4 inches wide. Calculate the area of each image and write it in the center of the image. Now, we should know how to do the image on the left, the normal image, because that represents a rectangle. We have not yet talked about how to figure out the area of a trapezoid, so try your best. Come up with some kind of formula, see if you can figure out what it might be. And in number 5, it asks to compare how the areas of the images compare. So go ahead and do number 4 and number 5. If you look at the area for the normal image in number 4, you should have come up with 2,080 square inches. The length was 40 and the width was 52. Remember, each of those squares are 4 by 4, so that's how we calculated that. 10 times 4 for the length and 13 times 4 for the width. Everyone's answers are going to vary for the trapezoid. I'm not even going to put anything in there. Hopefully, though, that the answers you came up with and comparing it to the normal image, maybe you saw that the normal image was greater in comparison to the distorted image. Take a look at page 865. We're going to skip number 6 and move on to number 7 and number 8. For number 7, it asks you to consider the distorted image in question 4. How can you use the area formulas that you already know to calculate the exact area of this image? Think about what we've done in 13.1 all the way through 13.3. We've looked at the areas of squares, rectangles, triangles, parallelograms now. So think about how you can use those formulas to help you figure out the exact area of this image. And then for number 8, I want you to try and calculate the exact area of the distorted image using those formulas. Go ahead. For number 7, you can split up the figure into a rectangle and 2 triangles. Then you can calculate the area of each piece and add them together to calculate the sum of all the areas and figure out what the area is for that distorted image. In order to find the area of the distorted image for number 8, first let's look at the rectangle. Remember, the formula is length times width. 40 times 36 is going to give you 1440 square inches. If we look at the triangles, Remember, the formula is half area equals half base times height. The height is 40 inches, the base is 8 inches. 40 times 8 is going to give you 320. If you cut that in half, you'll get 160. And if you multiply that by 2 again, since we have two triangles, you'll end up back with 320. Adding those two total areas together, 1440 and 320, should give you a sum of 1760 square inches. Take a look at number 9 at the top of page 866. How do the exact areas of the normal image and the distorted image compare? Answer that question with your group members. If you look at the areas for the normal image and the distorted image, the distorted was 1760, the normal image was 2080, so the normal image had the greater area. Take a look at number 10 on page 866. It says, consider the distorted image again. Suppose that you make an exact copy of this image, flip it vertically, and move it next to the image as shown. So you can see that new image is on that grid paper. What I would like you to do is answer letter A and letter B with your group members. Go ahead. For letter A, the geometric figure that is formed from these images is a parallelogram. For letter B, it says use a formula to calculate the area of the parallelogram. Again, we have to rely on our prior knowledge from what we learned in chapter 13. The formula for the area of a parallelogram, A equals base times height. So if you take 88 times 40, 88 was going to be the base, 40 was going to be the height. If you multiply those together, you're going to get 3,520 square inches. Now, in order to figure out the area of the distorted image, you're going to have to cut that in half. Half of 3520 is 1760 square inches. Hopefully, you can see that you came up with the same answer as you did previously. Take a look at number 11 at the top of page 867. You had two methods that you used in order to find the area of those distorted images. Do you think, what was it easier, to calculate the area of the distorted image by using your method in question 7 or by using your method in question 10? Just kind of go over and talk about that with your group members. We should already know that what we have talked about so far in problem 1 for 13.4, that the distorted image is indeed a trapezoid. A couple of key terms here though. The parallel sides of a trapezoid are called bases of the trapezoid. Non-parallel sides of a trapezoid are legs of the trapezoid. So you have to make sure that you can differentiate between the two. The parallel sides of the trapezoid are bases. The non-parallel sides are legs. Just to make sure we understand, in trapezoid TRAP on the grid, all I did was mark the two bases in black and the two legs in red. A little easier for you to see then. You should be very familiar with these two words at the top of page 868. The altitude of a trapezoid is a line segment drawn from a vertex perpendicular to a line containing the opposite side, and a height of a trapezoid is the perpendicular distance from a vertex to the line containing the base. Again, the height is just the length of the altitude, much like we talked about with parallelograms back in 13.3. If you take a look at number 12 on page 868, it says, consider the trapezoid shown. Suppose that you make an exact copy of this trapezoid, flip it vertically, and move it next to the trapezoid as shown. Label the bases of the trapezoid on the right. What we are going to be doing is coming up with a formula to find the area of a trapezoid based off of the area of the trapezoid that you found in question 10. We're going to use that example to come up with our formula for the area of a trapezoid. So go ahead and label, like it asks you to, the bases for the trapezoid on the right, and then answer letter A and letter B with your group members. If you're having a little bit of trouble Go ahead and fast forward. You can see what those formulas are then. I think it'll come a lot easier to you once you see what the formulas are in order to figure out the area of a trapezoid. So there is what your trapezoid sides should look like if you label the bases of the trapezoid on the right. Remember, it was just copied and flipped vertically, so base 2 is going to be up at the top and base 1 is going to be down at the bottom. If you look at letter A, it says write a formula for the area of the entire figure. The figure that you now created after you copied and flipped looks like a parallelogram. So you're going to add the two bases together and you're going to multiply that by the height in order to find the area of the entire figure. If you look at letter B, then it says write a formula for the area of just one of the trapezoids. Well, if you had a parallelogram which made up the entire figure, and half of that figure is one of the trapezoids, then you're going to take base 1, you're going to add it to base 2, you're going to multiply it by the height, and then you're going to take half of that. So the area for just one of the trapezoids would be A equals 1/2 times the quantity of B1 plus B2 times the height. If we turn to the top of page 869, using that formula now that we know to find the area of a trapezoid, go ahead and answer number 13, A, B, and C. This is very similar to what we've done in the last couple of lessons. This time it says for each trapezoid, either a height, the length of one base, or the area is unknown. Determine the value of each unknown measure. Go ahead and do that with your group members. If you take a look at letter A, we need to find the area that is the unknown measure. So we are going to take A equals 1/2 times the quantity of 6 plus 22. Those are my two bases. And we're going to multiply that by 8. That's my height. You end up with 112 square millimeters for the area of that trapezoid. For letter B, the unknown measure is the height, so we're trying to figure out what that is. We know the area is 25, so 25 is going to equal 1/2 times the quantity of 7 plus 3 times h. If we follow through with our formula, the height of that trapezoid is going to be 5 feet. If we take a look at letter C, we have to find the length of base 1 up at the top of the trapezoid. This one is a little tricky, so just make sure you follow along with the steps. So we have 45 is equal to 1/2 of the quantity of B1 plus 9 times 6. In the second step, you can see that I have 45 is equal to 3 times the quantity of B1 plus 9. I got that by multiplying 1/2 times 6. That's how I got 3 outside of the quantity. Now if you distribute in, you have 45 is equal to 3B1 plus 27. Again, you want to try to isolate that variable, so we subtract 27 from both sides, and we get 3B1 equals 18. 45 minus 27 is 18. And then if we get the variable by itself, we divide both sides by 3. 18 divided by 3, B1 is going to be equal to 6 meters. That's a multiple step equation. I know we've only talked about really one step equations so far leading into this type of problem. So if you had a little bit of trouble with this one, I wouldn't worry too much about it. We're not going to see a lot of problems like this. Just make sure you're focusing on what the formula is for the area of a trapezoid. That's the most important. Let's finish up then on page 870 up at the top with number 14. It says the projector in problem 1 was tilted differently now to create the distorted image that is shown. Each square on the grid represents a square that is 4 inches long and 4 inches wide. So go ahead and figure out the area of the distorted image, and how does the area of the distorted image compare now to the area of the normal image. Go ahead and do that with your group members to finish up. If you take a look at letter A, it says what is the area of the distorted image. B1, base 1 is 40 inches, B2 is 56 inches, and the height is 48 inches for that trapezoid on the right. So using your formula to find the area of a trapezoid, that's what your work should look like. Your answer would be 2,304 square inches. If we take a look back at the original normal image that we started with, if you remember, that was 2,080 square inches. In this example, the area of the distorted image would be greater than the area of the normal image. What I would like you to do then is take a look at problem number 2 for homework. Very similar to what we did in some of the previous lessons. You're going to take a look at some composite figures and try to figure out the area of shaded and unshaded regions. Please let me know if you have any questions in regard to finding the area of a trapezoid or the formula for finding the area of a trapezoid. Thanks.